What is latent heat and specific heat capacity? Latent heat can also be known as enthalpy and is denoted by delta H. And it's the heat energy that's required to cause a phase change in a substance without an associated change in temperature, and it's measured in joules. So if we heat a substance, let's take water, over a period of time, we can demonstrate how delta H is not associated with a temperature change. So let's heat solid water up to the melting point of 0 degrees C, or ice point. Then any further heating is not associated with a change in temperature of the substance because it's required for the delta H of fusion as we convert it to a liquid. If we heat the liquid, once we reach the boiling point, then any further heat energy goes towards the latent heat of vaporization to convert the substance to a gas, which is at the boiling point. This is assuming 1 atmosphere of ambient pressure. And at 1 atmosphere of ambient pressure, the SVP is equal to 760 millimeters of mercury at 100 degrees C. Specific heat capacity, on the other hand, is the heat energy that is required to raise the temperature of a substance, 1 kilogram of that substance, by 1 degree C or 1 Kelvin. And this is associated with a temperature change without a phase change, and it can vary depending on the phase of the substance. If we take a kilogram of water, the specific heat capacity is 4,200 joules per kilogram per Kelvin. If we need to heat water from 10 to 30 degrees C, that takes 84 kilojoules. If we need to heat water from 0 to 20 degrees C, on the other hand, we need the same 84 kilojoules that was required to heat the substance, plus the delta H of fusion, the latent heat of fusion, for converting solid to liquid, meaning that much more heat energy is required, so 417 kilojoules in total.